Our next step is to look at what RTH might be. I'm going to talk about RTH in terms of the short circuit current. Let's see what I mean. I have VTH, which was my open circuit voltage. I have this RTH, so now let us assume we know what this is. We know what that voltage is because we've analyzed the previous circuit and found it to be some number. Here are my terminals A and B. If I connect A to B directly with a short, then I have a current flowing through here, and by Ohm's law, I equals to Thevenin over Thevenin, or rearranging, Thevenin is Thevenin over I. Typically we call this ISC, I short circuit. So if I could find the short circuit current, I can use that to find RTH. Let's go back to that original example we had in the last video. I'll put it up on the screen for your reference. The original circuit we were dealing with, I have some source voltage here. I'm doing everything in general, just so that we can get comfortable working with algebra. And I had my two terminals A and B. Now I would like to know the short circuit current. That is the current, equivalently, that I connect A and B to. Notice that this terminal A and this terminal B are the same terminals as I have in my Thevenin equivalent. And I'd like to know the current here through those terminals. I can use some analysis techniques. Notice how these two resistors are in parallel with a short circuit, which means essentially they are bypassed. And my circuit becomes R1 back to Vs. So I short circuit is going to equal to V source over R1. We're almost done. Remember, we also had, from last video, Thevenin was equal to R2 plus R3 over R1 plus R2 plus R3 V source. Therefore, Thevenin is given as, it's a little bit more of a complex expression we might say, R2 plus R3 times Vs over R1 times R1 plus R2 plus R3. Where did that come from? Well, Thevenin is this. We're dividing it by R1, so we have Thevenin divided by R1. And now we know what Thevenin is, which means we can replace it in our original circuit. Why would we do this? Let's take a step back and see. If we can replace our circuit with an equivalent Thevenin circuit, then we can start connecting other circuits together. Part of the keys of engineering design is modularity. I have a number of things that fit together. Ideally, I can analyze one on its own, the other on its own, connect them together, and understand how they'll behave in conjugate. The power of Thevenin says, yes, your circuit might be very complex, but that's okay because we can reduce it to a much simpler form for the purposes of connecting it to other circuits. Let's go over the steps. To find a Thevenin equivalent circuit. Step 1. Determine open circuit voltage. Step 2. Determine short circuit current. If I refer to this as VOC, or Thevenin, and this is ISC, then step 3, and determine our Thevenin equals Thevenin over ISC. And that's it. That is how we find the Thevenin equivalent circuit for any circuit that we have. In the next couple of videos, we'll look at a little bit of expanding this, first to talk about the Norton equivalent, and next to talk about a couple of simplifications we can make if our circuit is nice to us.